This is an explanation of Ecology 2, population density and growth notes. So we are talking about populations, calculating the density, and then how populations grow and what limits their growth. So population density is the number of individuals that live in a defined area. And there is a formula for calculating the population density. It's going to be the number of individuals divided by that area. Okay, so an example I could show you, let's say we had 15 deer in 2 square miles. Okay, so you're going to take 15 deer divided by 2 square miles. And so if you do that math, 15 divided by 2 means it's going to be 7.5 deer for every square mile. Okay, it is important that you put the units on the end there, okay, instead of just giving me a number. So the units are going to help define what your answer is. Now, there are reasons that population density or populations generally can change in size. One is going to be immigration, and that means there's a movement of individuals into a population. So, you know, this has kind of been a topic in the United States, people moving into the United States, immigration, and what that does is increase our population. And if you have people moving into a population or individuals moving into a population, then you have to have them leaving a certain area. So emigration is the movement of individuals out of a population. So if they're leaving their country or leaving their area, that means the population is going to decrease. So where are those people coming from? That means they are emigrating. Another factor that can affect the population is the birth rate. So more individuals are born in a population. If you increase the birth rate, that's going to increase your population. If you increase your death rate, then obviously you're going to decrease the population. So these are basically 4 factors that are going to change population size. Now, population growth can be divided into 2 categories. The first one that we talk about is exponential growth. And you've probably talked about this in math class. You've probably seen a graph like this before. Here's where populations increase dramatically over time. In the graph here, this is my population size, and this is time. And so it grows slowly, and then pretty soon we're talking about doubling. So 1 goes to 2, 2 to 4, 4 to 8, 8 to 16, 16 to 32, 32 to 64, 64 to 128, 256, and so on, okay? The reason we have a exponential growth in population is because there's no limiting factors to slow or decrease the population growth. And that'll kind of be our next topic. But really, they have enough resources for the organisms that we're talking about, enough food, enough space, enough whatever they need, and that population is going to continually grow. So a good example of organisms that can grow exponentially are going to be bacteria. Bacteria can reproduce about every 20 minutes. For some take a little bit longer, but you can imagine every 20 minutes, it's not going to take long for your population to increase. Another type of population growth is logistic growth. And this is typically what we see in an ecosystem. So what happens in logistic growth, that the populations are going to increase over time, but they're going to level off. And another term that we see here is something called carrying capacity. So that's the maximum number of organisms an environment can support. I use an example like my fish tank that I have in my classroom. It is only a certain size. and I can only fit so many fish in that fish tank. If I try to put more fish in that fish tank, what happens is they don't have enough oxygen, and some of them are not going to survive. So the carrying capacity is the maximum number of organisms an environment can support. There has to be enough resources, enough oxygen, enough food, enough space in order for them to survive. And so limiting factors are going to prevent the population from the continual increase. So if we take a look at the graph here, again, this is the population or number of individuals, this is time. You're going to have an increasing rate, and then pretty soon what happens is it's going to level off because it's reaching its carrying capacity. So whatever factor is present in that environment, it's going to limit that growth. Okay, it may go up a little bit, but then eventually it'll come back down, and then it'll go up and come back down. So it reaches what we call the carrying capacity. Now, there are limiting factors, as we talked about up here, prevent the population from a continual increase. So when we take a look, there are actually two different types. One is density dependent. So density, as we talked about, number of organisms in an area. Dependent means it relies on it. So that means if it's a density dependent factor, that means it's affected by the number of individuals in a given area. So competition, if you have more organisms that are competing, that's going to be a limiting factor. If you have more predators, then that's going to be a limiting factor for your prey. If you have parasites, okay, parasites are going to spread, disease is going to spread when you have more organisms. So that's going to be density dependent. If we have something that's density dependent, we're also going to have something that is density independent. So these are factors that affect the population not based on the number of individuals. So climate changes, temperature, natural disasters, that's going to be an example of density independent. Okay? Independent means it is not relying on the number of organisms present there. So classic examples, again, climate change, natural disasters, anything to do with temperature changes, those are going to be density independent. So this is a review of population density and population growth.